So now we're going to explore the advantages of having a BPM solution in the cloud. The obvious advantages is cost, so I think we have covered in detail. But not every time, cost is an advantage. So sometimes it depends on the usage. So it's actually basically, buying a car and renting a car. If your usage is going to be pretty much, then probably, buying a car would make sense than renting a car. So the same applies to having to have a solution on cloud. If your organization needs heavy usage, then probably, it's better off with an on-premise solution than going for cloud. But having said that, cloud definitely reduces the entry barrier. So apart from the cost benefit, what are the other advantages? So one significant advantage of having a BPM solution in the cloud is the scalability, the scaling nature. So increasing business demands put great emphasis on scalability. In today's world, global businesses needs to expand to different geographies. It needs to extend its portfolios, and it needs to onboard new domains in terms of mergers and acquisitions. So how can an IT department within an organization be flexible and agile enough to handle such business demands? So when an organization acquires another organization, your IT department should be flexible enough to onboard the new acquired organization as quickly as possible. So this is possible with one of the inherent cloud architecture known as multi-tenancy. Multi-tenancy is basically the ability of a software program to host multiple tenants, with tenants not being aware of other tenants. So in a large organization, if you have different portfolios, and if each portfolio requires a separate domain, probably it's going to be the same shared infrastructure within a cloud-based BPM solution that will be shared across different portfolios. So when you have such an architecture, it's needless to talk about the cost advantage in terms of licensing. So it's a single license that's kind of shared, or it could be a subscription-based model, based on demand as well. So when the business expands, it will be a matter of days to provision a new portfolio or a new domain or to scale a new geography. The reason being, it's your cloud provider who is responsible for provisioning a new domain or a new server in the cloud altogether. That's kind of outsourced from an organization. So imagine an organization procuring a server and provisioning it and setting up the network. It would take months. And with the cloud provider and with the cloud-based BPM solution, it's going to be days. So that's a significant advantage. So another advantage is the dynamic scaling. So again, dynamic scaling is an inherent cloud architecture. So what I mean by dynamic scaling is the ability to provision a new virtual server on the fly, dynamically, on demand. Let's again go back to the fictional example of the Bank of Neverland. So let's say the bank operates in a North American region and it serves some of its BPM requests. So basically in the diagram you could see there are cloud service consumers, which are basically the Bank of Neverland service requests coming into the cloud provider, and an automated scaling listener listens to the incoming requests and it maintains a threshold. And the cloud provider serves the requests by passing it to the BPM server. So what if there is an increase in the number of requests? This could happen during end of the month when there's a lot of payroll processing to be done, or in a retail industry, if you could imagine, during a festival season, there will be a lot of activity, so increasing your business transactions. So there will be a sudden increase in the number of requests. So how will you handle such a demand runtime? And also we have seen a number of instances where the retail websites go down just before the holidays. So how can somebody handle that kind of a situation? And a cloud provider can do it for you. If you have a solution on cloud, basically when there is a surge in requirements, when there is a surge in the requests, an automated scaling listener listens to it. When the number of requests go above a certain specific threshold, the automated scaling listener interacts with a resource replication component which provisions a new BPM server. Actually, hypervisor is responsible for provisioning the new server, but it's not shown in the diagram. You could imagine a hypervisor replacing the resource replication component. So dynamic scaling is pretty much like a horizontal scaling in a cluster. So new BPM servers are provisioned on demand, and everything happens at runtime without manual intervention. We'll quickly see another scalability aspect within the provider. So it's elastic resource capacity. So here, instead of provisioning a new server, the resources within a server will be increased, like in terms of subpools or CPU subpools. Again, an automated scaling listener will listen to the incoming request, and when it goes to a specific threshold, the automated scaling listener will the signal intelligent automation engine to provide more results in terms of CPU or memory. So basically, somebody can write rules in the intelligent automation engine on what kind of memory or what kind of processing power they would require. So the dynamic scaling and the elastic resource capacity forms the basis of a cloud burst architecture. A cloud burst architecture is nothing but a new BPM or a new virtual service are provisioned on the fly, on demand, on a different cloud altogether. So when a cloud provider, they themselves exhaust out of resources, they go to a new cloud provider. This could be within their entity as well. So this has some real good advantage in terms of having geographically dispersed servers. Say for example, when a business entity functioning in North America acquires a business entity in Asia, and they wanted to quickly up their infrastructure, IT infrastructure in Asia, with a cloud provider, with a cloud burst architecture, they can provision new servers in a different region altogether. And of course, your cloud provider need to support that kind of an architecture. But with today's technology, what I'm implying is it's possible. There are kind of legal implications within cloud provider, but it's definitely within the reach. So with inherent cloud-based architectures like dynamic scaling and elastic resource capacity, and also with cloud-based architecture, scalability goes to an extent that has never before imagined with on-premise infrastructure. So imagine, having such kind of scalable capacity within your on-premise infrastructure. You imagine the upfront investment cost required, you imagine the capital required, you imagine the maintenance cost required. So all this is down, and still you get the ability to scale up and scale. And the cool thing is you only pay for what you use. So these are some of the serious advantages of having a cloud-based solution, especially when you put a BPM solution. So when your business expands, it's just a matter of days to provision a new server, and sometimes with a cloud-based architecture, it could happen on demand and on runtime. So having seen the advantages of a cloud-based BPM solution, we'll quickly check out the security challenge. So even today, a lot of organizations are reluctant to move towards cloud because they're unsure about how secure their data is, how secure their IT assets are. That's of course is one challenge. The other challenges are the cloud availability as well and network latency. But to address the security as service, so you can think identity as a service as a single sign-on in cloud. So in today's scenario, an organization needs to interact with a lot of SaaS-based applications, and this is going to grow for sure. So basically, within an organization, a lot of needs to log into a SaaS-based portal and multiple SaaS-based portals. So each time, they can't have their credentials passed to the SaaS-based application. So instead, they'll offload the security authorization and authentication to an identity as a service provider. So basically, the identity as service provider will act as a single point of security enforcement point. So let's quickly see how it works. So let's imagine a known agent, logging into your portal. So basically, when he puts in his credentials, the credentials are picked up by the identity as a service provider, and the identity of service provider interacts with the corporate LDAP, via IDA's agent. And once the IDA service gets authenticated, it's going to pass on the assertion to the SaaS-based applications. So in this example, we have seen, how a user in a web portal gets authenticated into a SaaS application. But it's just not only a human that is required to get authenticated. It can be a request or a transaction as well. So basically, the IDA has a capability to insert assertions into a particular request so that it gets authenticated or it gets authorized, and it can propagate into multiple SaaS applications. So some of the leading identity as service providers are Ping Federate, Empowered Identity, Active Identity, and there's a bunch of other service providers probably you can just check out by Google. So another probably a straightforward approach to handle the identity management is to copy over a corporate LDAP directory structure to a SaaS-based LDAP, or simply you make your SaaS talk to your corporate LDAP, which is behind your firewall. This is kind of undesirable, having corporations reluctant to share their LDAP directory structure with the cloud-based SaaS application. And also, when your number of SaaS-based interactions grow, you have to do this kind of a synchronization over time and again. So the ideal solution is to have an identity as a service provider, wherein you put your security in a hub and interact with your increasing cloud-based needs.